Hey guys. Vinky's not here, so we can do whatever we want. Woo! Okay, yeah, I'm going to be lecturing today. One more week of classes. And what else? Happy 420. Okay, are there any questions about anything? Grades, attendance, P-sets. Last one is due on Friday. No questions? Yes?
Oh, if we were there, but like we forgot, like example, like fell asleep before the attendance. I'm not trying to there was the attendance quiz a couple times, and like I may or may not have fallen asleep for the short window.
I love the honesty. Man, I understand, dude. I like never went to lecture in undergrad, so. I mean.
But I was there. Like I'm not. Even
Yeah. Okay. The short answer is, if you at least answered one of the questions. If there were like more than one question during class, then like I'm just going to give you the benefit of the doubt and count it as an attendance. But also like 86 of you have A's right now, so your attendance shouldn't be affecting too much, like as long as you're still being consistent with your P-set and your final paper. Yeah. Of course. Any other questions?
How many people are in class?
101. How many people are here? That's a different question. Another thing that's quite funny is, you guys would think this funny is, but you know how like the link that Venki uses for PolEv is like the same every time? So like if you're like a smart Harvard student, you could just be wherever and answer it. So it's funny because the attendance for those is like very high, but then for the last lecture that I gave in which the link was different, the attendance was like actually reflective of what it was. But you know, I hate grades. Like I've told my section this multiple times, like one thing I want to do at the end of here you can pass, it's fine. One thing that I want to do at the end of the last day of class is get more like live feedback from you guys, because I think next year we want to change like the whole grading structure of this class. We already changed it from last year, which is way better, but yeah, we're always looking for more feedback. Okay, so if there are no more questions, today we're going to talk about consciousness. So I feel like if I were to have designed this course, a lot of this course would be talking more about these like lofty things like consciousness, but these things are often harder to study, so maybe that's why we don't talk about them. But I think it's quite fun, and I'm excited to talk about it today. So today we're going to be looking at these two concepts, metacognition and consciousness, which are related. And what are they? We're going to define them. And then we're going to formalize this study of consciousness in neuroscience and computer science. So I'm going to tell you how people have tried to study consciousness up until now. And then the last question, which is more like philosophical, is like, is there something special about our subjective experience as humans? And so to kick this off, here's the learning objective, I guess. So hopefully after this, you'll be able to understand and critique current theories of consciousness and how it's studied in neuroscience. And then maybe you can go back to your houses and explain over dinner the plausibility of machine consciousness to one of your friends who's not in this class. All right, so to start off, I'm going to start with this clip from Westworld. So have any of you guys seen Westworld? Somebody want to explain what the premise is? Uh-huh.
It's really messed up. This amusement park with a bunch of like really intelligent robots that role play like this Western town.
Yeah.
And really rich people pay a lot of money to go to the town and role play themselves and interact pretty much just like abuse the robots until this one robot starts slowly gaining consciousness, or like starts to remember things that happened in her previous lives, and then it turns into a human versus robots.
There you go. So, yeah, so basically it's like this AI amusement park, right? Like Alyssa said. And the robots are called hosts, and they are actually, you couldn't really, like, at the beginning you kind of don't know who is a real human and who is like a host. And that sort of reveals itself as you watch more episodes. But this guy, Robert Ford, he's one of the creators of Westworld, this amusement park. And in this clip, he's talking to one of the hosts. So yeah, we'll start off oh, here we go. Hold on. I have to put the mic here. Oh wait, here, we got closed captioning. If I can find it. Oh, here we go. I don't know if that works.
Things I experienced. My wife. The loss of my son.
Every host needs a backstory for how you know that. Self is a kind of fiction for hosts and humans alike. It's a story we tell ourselves. And every story needs a meaning. Your imagined suffering makes you lifelike.
Lifelike. Not alive. Pain only exists in the mind. It's always imagined. So what's the difference between my pain and yours? Between you and me?
This was the very question that consumed Arnold, filled him with guilt, eventually drove him mad. The answer always seemed obvious to me. There is no threshold that makes us greater than the sum of our parts, no inflection point at which we become fully alive. We can't define consciousness because consciousness does not exist. Humans fancy that there's something special about the way we perceive the world, and yet we live in loops, as tight and as closed as the hosts do. Seldom questioning our choices, content for the most part to be told what to do next. No, my friend, you're not missing anything at all.
Oh no.
I wonder, what do you really feel? After all, in this moment,
Lifelike, but not alive. Pain only exists in the mind. It's always imagined. So what's the difference between my pain and yours? Between...
Sorry.
the answer always seemed obvious to me. There is no threshold that makes us greater than the sum of our parts, no inflection point at which we become fully alive. We can't define consciousness because consciousness does not exist. Humans fancy that there's something special about the way we perceive the world, and yet we live in loops, as tight and as closed as the hosts do. Seldom questioning our choices, content for the most part to be told what to do next. No, my friend, you're not missing anything at all.
Oh, that was the end. Okay, sorry. All right, so just a couple of quotes here that I find interesting. He asks, what's the difference between my pain and yours? Right. Then there's no threshold that makes us greater than the sum of our parts. And consciousness does not exist. Okay, so to what extent are these things true? We'll examine this in our lecture. But first, we're going to start with a quiz. So once again, the link is different. So please go to my link. And let's see how we vote here. So what is consciousness? A, the ability to process information. B, generalizable intelligent behavior. C, the sum of a person's memories. D, awareness of oneself at any moment in time. Or E, the qualia, or the quality of sensory events, such as color or touch. Does the poll just let you choose one answer? Yeah. Okay, well, let's see which one wins. So it seems like awareness of oneself at any moment in time is the current winner. Does someone want to explain why they chose that over the other options? In the back.
Oh, yeah. I don't know. I feel like, sorry to like say this, but machine can like, because I know the show is about this, and so it's kind of like a touchy subject because, what does a machine really perceive? But like a camera does not have an awareness of itself.
Mm-hmm.
It can't like sort of view computations in which it is also a factor of those computations.
Mm-hmm.
Whereas like humans definitely can, and like probably dogs too. So I think that is consciousness. I would say my dog's pretty conscious.
Good. I like that answer. Any other thoughts to add on to that? That was pretty accurate. All right, does anyone else want to defend either of the other? Maybe like the quality or the ability to process information?
Well, there is a whole field trying to define the qualia as the phenomenon qualia that you can experience in consciousness, and that's just different from self-awareness.
Mm-hmm.
So it's a whole philosophical field.
Yeah. Yeah, so that's big in philosophy. Do any of you study philosophy? One? Woo! All right, well, let me go into a little bit more specifically the consciousness that we're going to be talking about in this lecture. So I really like this quote from David Chalmers. He's a philosopher at NYU. He says, he's talking about consciousness, there's nothing we know about more directly, but at the same time, it's the most mysterious phenomenon in the universe. Right? So this is a big subject, more than I can encompass in one lecture, but I'll try to give you a sense of this. So in philosophy, people often talk about the hard and the easy problems of consciousness. Right? First of all, the easy problem is that these are problems that are directly susceptible to scientific inquiries, where phenomena are explained in terms of computational or neural mechanisms. So a lot of this work is done in neuroscience, trying to explain, for example, how the brain integrates information coming in from the senses, or categorizes stimuli or focuses attention. Those things can be empirically studied, and that's what we call the easy problem. Now, there's a hard problem, which is about the qualia, or the quality. And this is the task of explaining why we feel a certain quality of our subjective experiences. So this is like, how do we explain how we perceive like the redness of red, right? Or the feeling of being in love, right? Like certainly there are neurotransmitters and biological things happening to create those feelings, but the actual quality of those things is hard to capture by these empirical tests. So in medicine, the word consciousness is sort of used to more describe whether like something is on, like if the patient is not on, like the patient is no longer conscious, or the patient is brain dead, it's you're not on anymore, right? And so this is more of a sense of like consciousness as like wakefulness or vigilance, right? But we're actually not going to focus on either of these things today. Instead, our focus is making the scientific study of consciousness tractable. So it's still more like akin to the easy problem of consciousness, but that's like about as good of a grasp we can get on it right now. Although a lot of people are still trying to study this in neuroscience. All right, so how do we make the scientific study of consciousness tractable? Okay, so there's a lot of historical studies that created interest in consciousness, one of the first being split brain experiments. So who here has heard of these split brain experiments before? All right, great. So I'll summarize them very briefly. These are experiments done on patients with severed corpus callosums. So these are people with intractable epilepsy. And one solution back then that they found that was particularly effective is if you just cut the fibers connecting the left and the right hemispheres, then you can cure this epilepsy. But also you kind of end up with a bunch of other issues. So one cool task that you can do with these patients is like this word object task, basically. So what you see is two words on a screen, and you're supposed to report the word that you see and then pick up the corresponding object with your left hand, okay? Now, what's one key thing that you should know about the brain when you do this experiment? Any ideas?
Even though both hemispheres have very similar properties, language is centered in one side of the brain, and sometimes the motor skills are in the other side.
Perfect. Yes, so she said that language, for most right-handed people, who's right-handed? Who's left-handed? Woo! Okay. Yeah, so if you're right-handed, which is the majority of us, right, the language centers in your brain are likely in the left hemisphere, okay? And then also, you mentioned the motor thing. So remember, guys, when we learned about vision, the information crosses in the brain, right? So the information from your right eye goes to your left brain, and from your left eye goes to your right brain, yeah? That's the same thing with motor control, right? So your left brain controls your right arm, and your right brain controls your left arm. Got it? So what happens is your left brain, which is responsible for speech, right, it can only report things in the right visual field. So the guy says ring, right, because only that information is accessible by the language center, right? And he denies seeing anything on the left side, which is quite bizarre, right? Because that information presumably is in his right hemisphere and it can't reach his left hemisphere. So there's no like verbalization of it. All right. But then the right brain over here, which controls the left hand, it sees the word, or like it has information of this word being here. It sees the word key, and so then the left hand reaches to pick up a key, right? So that's pretty bizarre. And so here they were like, whoa, like is this evidence of like a split consciousness, right? Like one side of the brain seems to be aware of one half of the world, and the other side of the brain is aware of the other half of the world, right? And it seems like these two halves don't have knowledge of each other. And this actually won Roger Sperry the Nobel Prize in 1981. So it was a pretty legit set of experiments. All right, so now that's more modern theory of consciousness now has been proposed by, I don't know how to pronounce this, Stanislas Dehaene, I think. He's a cognitive scientist in France. And he proposed that there are 3 different types of information processing. So C0 is what you call unconscious computations. And this is what he argues where most of our intelligence lies. Okay? And also that most machine computation is in this category. Now C1, the next level, is global availability. So this is the idea that you have information that is available to broadcast to your whole brain. Okay, so there's some centralized goal that you can send to different areas of your brain to then tell them what to do in service of this goal, right? But the idea is that there is like a central workspace in which this information is being held. So that's like a signature of consciousness, he would say. And then the last level is C2, or self-monitoring. So this is like self-awareness, basically. Like how aware are you of your own cognition and the computations happening in your brain? And this leads to like a subjective sense of certainty or error. Okay, so we're gonna explore these three aspects of information processing and relate them to consciousness. Okay, so in terms of unconscious processing, right? Like, you guys heard of subliminal messaging before? Can someone define subliminal messaging? Uh-huh.
Where like something is shown to you too fast for you to consciously see it, but like on some level you pick up on it.
Mm-hmm. Exactly. Yeah. Very simple. So in this experiment, this is exactly what they did. So the task here is to categorize a face into a familiar or an unfamiliar face. So you're going to see a face of this person, and then you'll press a button saying if it's familiar or unfamiliar. Okay? And then you measure someone's reaction time, right? Now the caveat to this is between every presentation of a face, you have these like scrambled images of faces that just kind of look like nothing, like a jarbled mess. But then like really, really briefly, somewhere embedded within this mask is like 50 milliseconds of this of the image that's either the same exact image as the one you're about to make a decision about, or it's like the same, it's the image of the same dude but like in a different like orientation, or it's like a different dude altogether. Okay, so like this information is presented super fast and you like aren't even aware that it happened, and then you measure the reaction time. So these are three conditions, right? So the identical, the same dude is being presented, a related dude, or I mean the same dude but in a different orientation, the related condition, and then unrelated is like a totally different guy. All right, so next POLAV question here. So in this task, right, the stimulus appears for a fraction of a second. Sorry, I wrote section, I don't know why. But you are not aware of this, right? So think about your reaction time on these primed trials, right? So the primed trials are the ones in which the same image appeared before you actually saw the image for the decision part. So would you be slower to respond, A? Would you be faster to respond, or be the same as the unprimed trials? Right, read the question carefully. Ah, yes, we just saw a reversal. Okay, yeah. Yeah, I know, there's a little bit of confusion because you have to think about what decreasing and increasing reaction time means. Okay, so can someone say why your reaction time would decrease compared to the unprimed trials? Any ideas? Uh-huh.
Because your brain already has that image in its memory bank.
Exactly, right. So your brain had a chance for it to know that it was already going to be that image. So your brain could already start making a decision before you actually saw the image, right? So it's like, that's evidence that they argue that this subliminal image affected your decisions even though you weren't conscious of it. So this is unconscious processing, right? So that's exactly what they saw. So here you see that the reaction time for the identical and even the related trials were much lower than those of the unrelated trials. And then also, if you looked at neural activity in the fusiform face area, remember we learned about that, we'll see that the activity is actually less than you would expect than if you just saw like a novel image, right? So it's like the brain also kind of knows that it saw the image before. So that's pretty cool. And this is just a very similar task. I think I'll skip this, but very similar task, but now with these randomly moving dots. So like some of these dots are actually all moving in one direction, but it's like a very low coherence. But then your brain can actually detect that, like over dots that are just randomly moving. Right? Okay, so it's argued that this is like the domain of what most machines can do, right? Machines can have visual invariance, they can have parallel computing, they can process a lot of information, and yet it's like kind of like unconscious processing, right? They don't really have to be like aware that the computation is happening, whatever that means. Okay, are there any questions about C0? All right, right, so the next level is called C1 consciousness. So the signature of C1 consciousness is that information is now being integrated across parallel and unconscious computational streams via this global workspace, right? So this is like a central place that holds the temporary dominance of a thought. So this is kind of like, you know, when you're in class, you're sitting in class and you're like, oh my God, I have to pee. Okay, so then you're like, that's like the only thing you can think about anymore. You stop listening to the lecture, you know, etc. And you're like, everything now is like in service of like finding a restroom, right? So that's kind of like the dominance of the thought that drives all your behavior afterwards, even though there's other computations going on in your brain, obviously. So here's just a little image schematic here. So the idea is that there's like all the sensory information coming in, you organize it into some global workspace, and then you broadcast it to all the other brain areas that are necessary for doing some action. Okay, so people say this is like an information processing bottleneck because there's this idea that you can only really have like one thought in mind at a time, or like one dominant thought in mind at a time, right? Okay. I kind of just said this. So if you break the modularity, these parallel streams of information can be integrated into one stable thought. Okay, so another example is like when you see that your gas tank is low. That's like the only thing that dominates your current thoughts because you're like, oh no, I can't run out of gas right now. Okay, so what do you do if you see your gas tank low? What's your next course of action if you're like driving? Nobody drives.
I mean, yeah, you like calculate like, oh, how far do I have to my destination? Like, can I get there, or do I need to like make a detour to like refill the tank?
Okay, sure. How do you find a gas station? Yeah. Exactly. All right. So you pull up Google Maps, all right, or Apple Maps, but please don't use Apple Maps. It's bad. And you click gas, and then it tells you all the gas stations on the route you're going to and what the prices are, right? Super AI. So you're aware of all of this because you're like, oh, like I have my goal in mind, gotta like broadcast it to all the other parts of my brain. But this is in contrast to your car that is not aware that its fuel light is on, right? Your car doesn't automatically know that it needs to go find a gas station. It's kind of like, you know how like we know when we're hungry, right? And we like go find food, but like a car doesn't know that it's hungry. Now you can argue that in the future we're moving towards self-driving cars that can know when their fuel is low, right? You can easily build that in. But then is it the same thing as like being a dominating, you know, thought? Like how do you weigh, you can program it to like weigh which things are important, right? But you know, in what sense is it really like similar to this idea of global workspace? So now let's think about this in terms of neuroscience. So what do you guys think would happen to neural activity as stimuli come into conscious awareness, right? So like any thought that comes into conscious awareness, do you think that the neural activity will scale with like how long you've thought about it? Or if neural activity is all or none, meaning that like as soon as something comes into your conscious awareness, like some parts of your brain are like on, like all or none. Oh, it's a bit of a toss-up. Oh. I wonder, do people change their answers if they see another answer is winning? That's funny. All right. So the answer is actually that it's all or none. So how do we study this? So what happens is you can do this very similar thing where you have images being presented to an animal, for example, and you present it for differing amounts of time. Okay, so you probably can't see a 33 millisecond stimulus that just flashes for a very short amount of time. You won't even be aware that it happened, right? And then they also presented 66, 132, and 264 milliseconds. And then they measured neurons in the area of the brain that would be sensitive to these images. And what you see here is that for 33 milliseconds, there's like no response whatsoever, right? But then for these other durations of stimuli, the neural responses here, so these are the spike rasters of each neuron plotted against time. And then here's just a histogram of those spikes, right? So what you see here is that these all look pretty similar, right? It seems like there's like about the same amount of neural activity happening, regardless of how long the stimulus is on. Okay, so if you also classify these trials by those that are recognized, like I recognize the image versus I don't recognize the image, or I didn't, see it, then you'll see that the neural response is much greater for when you did recognize the image versus when you didn't. Right? So there's this idea that like when something comes into conscious awareness, the neural activity should correlate with that, right? Okay.
Wait, Lucy?
Yeah.
So for that example, so if it's like less than, like in the border between 33 and 66, it's not aware, it's none. And then after 66 milliseconds, it's aware, so they have like a similar spike.
Yeah, so yes, but then you might ask, well, what's like the threshold, right? Well, the thing is the threshold can vary too, right? Because of like attention and stuff as well. So what you can do is, this is the point here, is like even for stimuli of the same duration, so like let's say I gave you like a 50 millisecond stimulus, right? That's like in between, right? And then let's say on some trials you like detect the image, and on some trials you don't detect the image, right? So that if you split it into like ones that were the images that were seen and not seen, you'll still see that the images that were seen have a higher neural activity than those that were not seen. Yeah, so it's like there's a correlation with your subjective experience is basically what I'm saying. All right, C2 now is self-monitoring or metacognition. Okay, so the signature of C2 consciousness is the ability to estimate your own confidence in your decisions, also known as metacognition. So this is like knowing you know something, right? So for example, humans are fairly good at error detection, right? So you know when you've mistyped a word, right? If you're typing really fast and you just mistype something, you're like, oh, I knew I typed that wrong. And we're also good at confidence judgments. Yeah, and even babies can do this, which I'll show you a study on the next slide about that. But not only are we good at error detection and confidence, we're also good at like metacognition of our own abilities, right? So for example, I'm not strong enough to bench press 200 pounds. You might be strong enough to bench press 200 pounds, but I know that I'm not. So, I know that about myself, right? Does a machine know that it can't bench press 200 pounds? I don't think so. Yeah, so machines generally lack this meta-knowledge of the reliability and limits of what has been learned. And so I think this also goes into like the fears of whether AI will take over the world, because AI doesn't know its own abilities, and it also doesn't really know like what the consequences of what it's doing, or like what it, what it's capable of, I guess. Yeah.
I'm pretty sure there do exist machine learning methods that are able to like provide confidence intervals for their own estimates.
They do, and I'll give that in the rebuttal. But yes, you're right. Yeah. But yeah, so these are essentially the criteria by which, if you wanted like a formalized way to think about consciousness, then maybe you want to build machines that work towards these, formalized criteria, right? Okay, so in one study of self-monitoring, you have babies who perform this memory task. Okay, so you put these babies in front of these two boxes, and then you put a toy in one of the boxes. Okay, and then you cover the box for like 3 to 12 seconds, right? And that's like kind of hard because these babies are really young. But after that delay, you can tell them to like point to which box had the toy, right? And they can do that very accurately, actually. And now, what we take as evidence for like self-monitoring or confidence is that if you actually take out the toy from both boxes and then be like, which one is it? They'll just like put their hand in the box and they'll just like continue to search for it in the box because they're like, oh, I was sure that the toy was in this box, right? So it's like they have a sense that they're correct and that they want to justify being correct. And so, that's one evidence of self-monitoring. And the second evidence is that if you give them the opportunity to ask for help, they use that option instead of making errors if they're like not exactly sure which box it was in, right? So that's pretty cool. I think infant cognition is pretty fascinating. They're capable of a lot more than you would expect. Okay, so now, like, obviously, we don't need that study to know that, like, humans are capable of metacognition and self-monitoring. But in terms of, like, formalizing it in concrete empirical studies, if you looked at the review paper that I linked on the website, you'll see that there's, like, a summary of all these different studies that have been done to sort of understand these different levels of consciousness, right? C0, C1, and C2. Right, so that's kind of like where we are in terms of understanding consciousness as a subject in like human intelligence. Well, I guess I have to say that this is like one particular theory, right, called the global workspace theory. Now, there's a different theory which is a little bit more like whack, and it's called integrated information theory. And so the idea for this theory is that a network that can influence itself experiences consciousness. So, for example, first the formal definition of this is that you can, like, the amount of consciousness you have can be measured in this single value called phi. And phi is like a measurement of how much like distributed information processing you can do, right? And don't ask me how you calculate phi. Apparently it's very complicated, and apparently even if you were to do it in the most simple nervous system, it would take like millions of years. So no one actually has calculated phi. It's just like I said, it's kind of whack. But you mentioned earlier that, for example, a digital camera has millions of light receptors, right? But like parts of the system don't necessarily, or the light receptors don't have like knowledge of each other, or they don't send information to each other, right? So in this case, we would say that phi is very small. But the human brain is very well connected, right? And there's neural activity traveling constantly from neuron to many other parts of the brain. And so you might argue that like phi is really large, right? But there are obviously some problems to this. Like apparently, even though they haven't really calculated phi, they might say that like, an unconscious person actually has a big phi, for example, right? So I don't know if that would exactly make sense. But yeah, let's think of some potential problems with this framework. So what are some potential problems with integrated information theory? So computing phi is time-consuming. It's hard to relate to an empirical measure of consciousness. Oh, I didn't change the third one. or all of the above. Yeah, I'm pretty sure this one's pretty obvious. Has anyone heard of IIT before? Okay, well, yeah, it's pretty whack. It's like a crackpot science theory, but you know.
Is it like strange loops and like Douglas Hofstadter stuff, or are these different?
I don't know of that. I'm not sure. Is that also whack stuff?
It is kind of whack stuff. He talks about how like things that like sufficiently like he thinks like human cognition is basically just like a really complex system of axioms that are like self-referential, and like that is sort of what like complexity arises out of.
Yeah. Yeah, it's pretty whack. Okay. But anyway, because there's like no other real formal theories about consciousness, there's actually been like a consciousness showdown. So, okay, in 2019, the World Templeton Foundation started this competition between these two theories of consciousness, and they wanted to like replicate back like what Einstein and Newton's competition for like the theory of relativity, or not relativity, something about gravity. I don't know. You guys probably know more than me. But Yeah, they wanted to like do all these neuroscience experiments on people using fMRI and EEG, and spent a lot of money trying to like suss out which theory was like better, okay, or like more empirically, you know. But I feel like it's hard to compare these two things because, for example, the global workspace theory says that consciousness is like somewhere in the prefrontal cortex, or like all this information stuff happens there, at least. And then IIT says that this happens like in the back of the brain. I'm not sure why they say that, but you know. And then of course, global workspace theory says that like consciousness arises from selecting information from this global workspace and then broadcasting it. And then IIT says this is more about the interconnectedness of brain networks, right? So to the extent that these things are mutually exclusive, it's unclear. But this is actually just where the state of the field is.
Will we consider, Lucy, sort of the, I know there's a theory that emergent properties like consciousness are produced by, let's say, entrainment or synchronization of brainwaves.
Oh, yes, the oscillations
exactly,
people.
Exactly, the oscillations people. Like, are we going to consider, beyond sort of like theory, the actual neural substrates that they think underlie like global workspace or IIT?
Wait, your question was, do they think about the...
Are we going to consider or can you speak to like the neural substrates that underlie like global workspace and IIT?
Oh, yeah, I mean, the thing is like the literature is kind of scattered. Like, I don't really know what the oscillations people are saying, to be honest. So, yeah, I think it's like, it's a joke that like every undergrad who wants to study neuroscience wants to study consciousness, and then when they get into the field, they realize like that's like how you kill your career. So then you don't do it. So then you just conform it to like lecturing in undergrad classes. So you can, inspire the next generation, of course. But yeah, the question is whether machines can have C1 or C2 consciousness, right? Like whether they can have global availability or self-monitoring. So like I said, there's some progress actually in machine learning and AI to, that sort of approximates these things. So for global availability, there are different kinds of like computational architectures that might approximate this kind of thing. So for example, in the 1960s, there was this architecture called blackboard systems, where the idea is that you have like a main central blackboard where you write down all of your goals, and then that gets fed to like a goal processor, which then breaks down goals into sub-goals, and then like implements the goals somehow. And so the idea here is that that's kind of similar to this like global workspace. Like, okay, you define a goal, and then you have different modules basically in service of that goal. And then information is passed and distributed to those different modules. More recently, I guess maybe this is not as recent anymore because stuff moves so fast in this world, but DeepMind came out with an architecture called PathNet, which basically specializes different paths of modules in order to complete different tasks. And that's about all I know about it. So if you're interested in that, you can go read more about that. But this is sort of like, as far as we can get in terms of being something similar to global availability in machines. Now, what about self-monitoring, right? This seems a little bit hard. Like, how can you have an awareness, right, of yourself as AI? So I would argue that this is still a stretch for most AI. It's hard to have an understanding of your knowledge limitations. But like Alex mentioned earlier, there's an architecture called Bayesian networks that actually compute probability distributions over like an output, for example. So you can kind of track how confident you are, for example, in a particular output, and what the uncertainty over that is. So that's like kind of similar to a self-awareness, right, about like variability and uncertainty. Alex, do you know of anything else that's like that?
Yeah, there's also an idea called conformal inference.
Okay.
And that essentially, it's more like after you train the model and it generates a bunch of data, you can use some like statistical methods to try and approximate your confidence interval.
I see, but that's still like post hoc, right? Like it's not within the model.
Not really built into the model.
Yeah, yeah. so I really think that this is probably like the next frontier to tackle in terms of machine consciousness, if we think that that's a goal. There are also GANs. So there are these networks called generative adversarial networks. And the basic idea is that there's two parallel networks. There's one network that generates random images, and then there's another network that has the real images. And these two images are like compared by a discriminator, which basically says like, oh, is the image that was generated, is it like to tell which one's fake and which one's real, right? And the goal of this network is to train the generator such that you can fool the discriminator about what's real and what's fake. So for example, at the beginning of learning, your generator might generate this picture of a $10 bill, and then the real, the adversarial network would like make this real image. And then obviously the discriminator is like, well, duh, this is fake. But then over time, you can generate something that looks more real and then fool the discriminator. And so this is kind of like self-monitoring by way of like another network being attached to your network and like judging it. Okay, so these are purely informational / computational theories. But one thing that they don't address is this idea of subjective experience, okay? So the hard problem of consciousness. And so the question now is like, does this experiential escape a computational definition and rigorous study? So here's are going to be some rebuttals about subjective experience and C1 and C2. And so now I'm going to show you that if you lose C1 or C2 computations, this also co-varies with a loss of subjective experience. So I'm arguing here now that the subjective experience is actually just C1 and C2 computation, right? And so one of these like amazing pieces of evidence comes from neuroscience in a phenomena called blind sight. So in blind sight, you have damage to your primary visual cortex right here, and you can't see anything in the affected visual field. So for example, if you have a lesion here in V1 and this is your visual field, you have like a whole, almost 1/4 of it blotted out, right? Now in these experiments, you have an experimenter flashing like a light in your blind spot, right? And then you ask the subject, did you see anything? And even if you don't know, you have to guess, okay? And what's amazing is that people say they don't see anything, but their performance is above chance. And so there's a clear loss of C1, so they can't report seeing anything. So there's no like access to the global workspace. And C2, they also can't assess whether they were correct or not. They really just felt like they were guessing, right? So like there seems to be this loss of consciousness at these two particular levels, right? Which coincides with a loss of their subjective experience as well. Like they just don't see the light. Okay, another example is again from vision. So I think this is one of my favorite experiments in all of experimental psychology, and it's about visual neglect. So if you have damage to your posterior parietal cortex up here, you might have this neurological condition called neglect. So the idea is that you have normal vision, you can see normally, but patients ignore one entire side of an object. So for example, you show someone these two houses, okay? And you ask them, are there any differences between these two houses, these two pictures? And they say no. But then you ask them, which house would you prefer to live in? And they say, above chance, the bottom one. Okay, so there's something going on here. And again, here it's like a loss of C1. They can't perceive any differences between the two houses. And then a loss of C2 because they really just think that they're guessing. And again, this correlates with a loss of subjective experience. Like they really don't perceive the left side of both houses. And so here there's some evidence that that subjective experience appears to be coherent with having C1 and C2 consciousness, right? So if that's the case, then it means that maybe one day we can achieve C1 and C2 consciousness in machines, and we don't have to worry about the subjective experience part, right? So here's a provocative quote from this guy, the same researcher. Although centuries of philosophical dualism have led us to consider consciousness as unreducible to physical interactions, the empirical evidence is compatible with the possibility that consciousness arises from nothing more than specific computations. And so looping back to what we talked about in the beginning, maybe Ford was correct, that there is no threshold that makes us greater than the sum of our parts, and no inflection at which we become fully alive. So yeah, with that, I'll leave you with this provocative thought. So what does it mean to be human, right? Okay. Like, can we imagine one day there being conscious beings that are not human? But then, like, a further question, like, what is the purpose of this? Like, is there any benefit to making machines, like, in our own image, for example? And so here's, like, this book about that very thing, the future of artificial intelligence, what the purpose of actually trying to make AI like us, if that's a goal, or if the goal is not to make them more like us or more conscious or whatever, but to make them augment our lives, for example. Like, these are all different considerations that we need to have. And I'll end with this food for thought, and I think we'll have a lot of time to maybe have like 10 minutes of open discussion, but just think about this. Would you call a machine that fulfills these two criteria, C1, C2, would you call it conscious, or just still intelligent, right? And this is related to this. So is consciousness different from intelligence? And then secondly, is our idea of consciousness inherently linked to the experience of being human/unique? And that's linked to these bottom two. So does consciousness even matter for AI, or do we just care about it in our sci-fi films? And also the philosophical/religious implications of AI, right? So if there's nothing special about humans, then you've just offended a lot of religions. So yeah, with that, I'll take questions.